Cool. Shall we get started?
Yep.
All right, everyone. We'll go ahead and get started. So I'm excited to introduce Allison Koenecke, who's our speaker today. So she is an assistant professor in the Information Science School at Cornell University, and her work focuses on algorithmic fairness, including applying computational methods like machine learning and causal inference to study societal inequities in domains from online services to public health. Dr. Koenecke is a regularly quoted expert on disparities in automatic speech recognition systems, which I don't know if you're talking about today, but it's work that I think is really exciting.
Thank you.
She also, before joining Cornell, was a postdoc at Microsoft Research, and she received her PhD from Stanford. Since joining Cornell, she's been the recipient of a number of awards, including NSF grants, and was also named to Forbes 30 Under 30 in Science. Great, thank you.
Thank you for that intro, and it's fantastic to be here. It is significantly warmer here than in Ithaca, so thank you for welcoming me with that. And yeah, as Anjali kind of indicated, I think about algorithmic fairness a lot. And maybe just to kick things off and give you a high-level overview of the types of things I think about in my broader research direction, a lot of it is informed by this question, right? So thinking about how algorithmic systems fail in high-stakes settings, but I also want to pick apart each of the kind of phrases in this overall research direction to kind of better situate how I think about my work. So in terms of how I actually pick apart these sorts of systems, I come at this from more of a CS econ angle, using tools like machine learning and causal inference to look at these systems. But perhaps most pertinently, a lot of my work is done in conjunction with some fantastic collaborators to provide that domain expertise in each of the kind of domains that I'm working in. So for example, I work a lot with linguists to kind of supplant the NLP expertise that is usually something that comes along with the speech-to-text work that Anjali mentioned. I work a lot with medical experts and biostatisticians, including many fantastic folks at Hopkins, especially in work in the public health space. I work with legal experts who can provide a lot of weigh-in on the extent to which AI systems might need to be regulated in the future, or how those sorts of legal systems might play out. And I work a lot with nonprofits and government organizations in thinking about how downstream users, for example, recipients of government benefits, might actually work in the real world. And so this is broadly how I approach these problems. So from a CS econ angle, but together with collaborators. And when I think about how these systems fail, I'm thinking about this specifically from a fairness lens. And in particular, if we're all using the same algorithmic system, but there is disparate performance for different types of demographic groups, something known as disparate impact, that's the type of failure mode that I'm focusing on in a lot of this work, thinking about algorithms that are differentially valid on different populations, especially heterogeneous populations. And in terms of the systems that I'm auditing, a lot of what I think about is speech to text. And so in gray, I have first and senior authored papers listed. And so, of course, this is the type of setting where we might not only think about the speech and language modeling behind these systems and how we might architect them and train them, but also working directly with linguistics experts and sociologists to better understand the overall systems and how specific pinpoints in these systems might lead to failures downstream. But on top of this, I also audit other types of online systems. So things like recommendation systems, online ads, LLMs, the last of which is kind of the natural progression from the speech to text work in the auditing space. And then the last part I want to pick apart in this overall question of how algorithmic systems fail is thinking about the actual settings themselves. So if we're thinking about the outputs of the algorithms, how are these going to affect the broader societal population? So the first bullet point here, which is what I'm going to touch on in the second half of my talk, has to do with the setting of budget allocation for government services. I'm going to focus on one of my papers, the 2023 ICWSM paper in this case, but I do also want to do a quick pitch for the NMI paper that came out this year, which was joint work with fantastic collaborators at Hopkins as well, Ben Nguyen and Liz Chin, where in this particular paper, we studied the algorithm that was used in order to allocate government money from the state of California to disadvantaged census tracts, where the definition of being disadvantaged was an algorithm-based definition based on various environmental and population health covariates. So fantastic work, check it out, support your colleagues. But past this, I also look at a bunch of other high stakes settings. So in addition to looking at government services, I also think about legal trials and how LLMs might play a role in capital cases for women, especially. I also think about clinical trials and public health, and a lot of this work is also joint with Hopkins collaborators, and also thinking about human annotations in broader AI systems, from Xbox labeling to political predictions. And so today I'm going to talk about two specific lines of research, one having to do with speech-to-text systems, focusing more on the algorithms themselves, and one having to do with government services, focusing more on the outcomes of the algorithms that are in the loop in the system. So with that, let's go ahead and get started with speech-to-text systems, which I'm going to now start calling ASR systems for short. So automated speech recognition is something that you can think of as effectively Alexa, Siri, any of these sorts of tools that you might use on your phone. You might ask for relatively low stakes things like, oh, set an alarm or find me a recipe for something, right? But actually, a lot of ASR services are now increasingly being used in high stakes settings, and I'll talk through a few of them in a bit. But just to preemptively tell you about the scope of the first half of my talk, I'll start by talking about this paper from 2020 in PNAS, which I lead authored as a grad student, and then go into a paper that I lead authored this year as a faculty member that came out this year as well. So firstly, ASR systems, why do we care? So there are a lot of kind of downstream applications that increasingly have ASR in the pipeline. If you think about a lot of the entry-level hiring at, for example, Fortune 500 companies, these hiring tools now broadly have ASR systems in the loop, where instead of actually being interviewed by a human, you're increasingly being shown a series of questions on a screen, and then your answers are being recorded. Your verbal answers are being transcribed by an ASR system. That is being sent into a model to decide whether or not you get a next round interview by an actual human, right? And so it's important to get ASR right in this pipeline. There are actual legal implications for discrimination in hiring, but also in general, right? We want to make sure that we're hiring reasonable candidates. As another example, we have products that are put out by companies like Axon. And so they are the largest provider of body cams to US police forces currently. And in addition to just having the body cams, they've recently rolled out a new product which takes in the audio feed from a body cam, transcribes it using OpenAI-based tools, and then takes that transcription and uses it to automatically summarize a police report. So the police officer only has to click, yes, submit this thing at the end of the pipeline, and that's how police reports are now generated as part of this whole end-to-end pipeline from the body cam directly to the written report that's the official record. So again, a really high stakes setting where you actually care a lot about getting the ASR transcription right. And if you think about body cam footage, you can imagine there are all sorts of additional, on top of the fairness and ethical implications, you have issues with noisy backgrounds, you have people speaking very quietly. So all sorts of ways in which the ASR portion of this can go wrong. And then the last piece that I'm going to give as an example of why I think ASR really matters is this particular product called Veris, which is used for prison phone surveillance. So effectively what happens is you have an incarcerated person who is on the phone on a prison phone. That audio is being wiretapped and sent through an Amazon AWS system for speech recognition. Those transcriptions are then checked for individual trigger words. So if the transcription contains the word gun or suicide, some sort of carceral decision is then being made. So for example, maybe you end up sending someone to solitary confinement on the basis of this Amazon-based transcription of what's being said. Right, and so again, this is another really high impact scenario where if the ASR is wrong, you can have these extremely negative potential consequences. But what I want to call out with this particular screenshot from the actual website is this part here where it says it's very objective. There's no implicit bias, no racial profiling. And much of my research agenda shows that this is very much not true. Any ASR system that you use is going to have some sort of bias baked in. And so I'm going to start by telling you about my first audit study that I mentioned, which has to do with racial bias. Okay, so in this study, hopefully you recognize all 5 of these logos. These are the big tech companies that we're auditing for biases. And what we do in order to perform this audit is first figure out what data we're going to use to perform the actual auditing. And so what we do is we have one corpus for our Black speakers, which is the Coral corpus, and another for our white speakers coming from the Voices of California corpus, which gives us about 40 hours of speech data. These are all in the format of sociolinguistic interviews, so the respondents are all being asked kind of a standard slate of questions, and what we're grabbing is the interviewee speech. So when they have this naturalistic dialogue in response to these questions. And what we also want to ensure is that we're not testing on the train set, right? We want to make sure that all 5 of these companies haven't already ingested these audio data, because otherwise they'll just have great transcriptions and there's no real point in doing this sort of auditing. So we did actually confirm with all 5 companies that they had not previously ingested these data. And the second concern that we have is we need some form of ground truth, right? So once we send all of these audio files through to be transcribed, how do we know if they're actually correct? And the answer is hardworking linguistics grad students who have already transcribed a lot of these files. And so we take those human-generated transcripts as our ground truth. And so we have both of these constraints satisfied. And so with that, we can get to running our audit. So first we do some audio processing. We segment everything that the interviewees are saying to reasonable sized snippets, audio snippets that end at the end of a conversational turn, for example, so at the end of a sentence, at the end of a phrase. And then we propensity match between the Black and white speakers that we have from our data sets on traits like age, gender, and duration. And so what we end up with is a set of about 2,000 audio snippets for Black speakers and a matched set of 2,000 snippets for white speakers, all of which are fed into an ASR system, which is a black box, haha. And so these 5 ASR systems then all create transcriptions for each of our audio snippets. And what we want to do is we want to compare how well each of these transcriptions do in comparison to the ground truth that were transcribed by the hardworking linguistics grad students. Question?
Sorry, propensity score matching. What was the treatment for the propensity score?
Great question. Treatment was, I believe, race. Yeah.
Okay.
Yeah.
I will have some offline questions.
Yeah. Yeah.
Yes. I had a related question. How many transcribers did you have? If you're comparing to human performance, you need to model the variability of human performance. And
so how many transcribers? We had quite a few. So the Voices of California data set was internal to Stanford. So
no. My question was for each recording, how many people transcribed it?
Gotcha. For each recording, only one person.
Okay, that really isn't a very good ground truth, but
it's true, but it is what we have. And we did have all of the transcriptions appropriately tagged by timestamp and using a standard set of tags for things like laughter and breathing and that sort of thing. We did do some additional validation of all of the ground truth that we had, and across the board, we saw pretty high accuracy. And the other thing I'll note is that because we had Black speakers in our sample who were speaking African-American English, all of our transcribers of the Black speakers were also speakers of African-American English. And so we did have consistency on that front as well. Yeah, question.
Yeah, so you'll probably talk about this, but when you measure the error rate, are you using a content neutral metric like word error rate, or are you interested in emphasizing more consequential errors?
2 slides from now.
Thanks.
Great question. Any other questions? All right, so this is where we ended. We want to compare our actual transcriptions to the ground truth. And indeed, what we use is the word error rate, which if you are a computer scientist, this is just an edit distance, right? But if we are thinking in ASR land, this is word error rate. So we're just counting up the number of changes between the ground truth and the generated transcription and dividing by the total number of words in the ground truth. So if we want to go from the transcription of that is a presentation to what a great presentation, we have to make 3 changes out of 4 words. And so we end up with a word error rate of about 75% in this particular example. And so this leads to this question of like, is 75% good or bad? This is actually extremely bad, right? High word error rate bad, low word error rate good. You can even think of 50% as basically unintelligible, because that means that every other word is going to be transcribed incorrectly, roughly, right? And so 50% already unintelligible, 0% perfect accuracy. And so what we find overall in our study is that Black word error rates are roughly doubled those of white word error rates. And this is fairly consistent across the board for all 5 of the APIs that we study. Okay, and so this is kind of the headline that a lot of the journalistic outlets that we worked with ran with, right? This big finding of Black individuals are having these doubled word error rates relative to white speakers. And it is true, that is the high level finding of our work, but actually I think much of the meat of our research lies in kind of the following 3 questions, which are ones that we work through in this paper. So firstly, how do we actually know that these are race-based and not something else, maybe by geography? Secondly, how do we actually figure out what specific portion of the speech-to-text models are leading to the doubled word error rates that we see? And third, what do we do about this, right? So to start things off with the first question, how do we know that these are race-based? So recall that we had our 2 sets of speakers from 2 different data sets. And so our Black speakers come from one of these 3 cities, Princeville, DC, or Rochester, and our white speakers come from Sacramento or Humboldt. And so you'll notice that the word error rates are higher for the Black speakers in the first 2 locations, but then we have this question mark over here with Rochester, right? We're seeing that our Black speakers in Rochester actually have quite low word error rates, comparable to those white speakers in Sacramento, for example. And so there is coverage across both urban and rural locations for both. That doesn't seem to be a huge difference maker by word error rates. So how do we explain the sort of Rochester situation? So in order to do this, we introduced something called the dialect density measure, which measures the extent to which people are speaking African-American English, which is something that about 80 to 90% of African-Americans in the US do speak. And so what we can do is actually tabulate all of the different linguistic features that come into play by having, again, hardworking linguistics grad students do this sort of encoding of different individual features. So what types of features are we talking about? These are both grammatical and phonological. So we might have, for example, the zero copula feature. So instead of having the phrase they are gone, ARE is the copula. If you have no copula, zero copula, you just have they gone as the grammatical formulation in African-American English. So that's one example of something that we would tag. We might also have phonological examples, so things like final consonant cluster reduction, where the final D in band isn't enunciated. And so what we can do is measure this dialect density measure for each individual audio snippet that we have and compare that to our word error rates. And so I'm going to play 2 examples for you, hoping that maybe if I set my volume to max volume on my laptop, folks in the room can hear. So the first example that I'll play, you can see, I'm kind of priming you. We have very few African-American English features. It's just this one blue highlight here. This example is going to be syllable initial fricative stopping. So the TH is going to sound a bit more like a D sound. And you can see also that the word error rate for this particular snippet is extremely low. So the ASR has messed up on exactly one word. So they mistranscribed grow as world. And I'm going to now play this snippet so you can hear what a low dialect density measure would sound like for one audio snippet.
Grow older,
Oh.
we get darker. So I was extremely light when I was a child and very skinny. And so I was like an outcast because I was made fun of because I was the white girl at the school.
All right, so let's now contrast that with the next example. So hopefully you can see where this is building up to. We now have an example with far more blue highlights, which are more African-American English features, and also a much higher, i.e. worse word error rate.
Well, our 2nd grade teacher gave me the nickname Snake because she said I was sneaking, you know. I'd be sitting one place and she turned around, I'm sitting someplace else.
All right. And so hopefully, again, you can see where I'm going with this. We want to compare dialect density measure to word error rate. And we do see that there's this positive correlation, right? So it does seem like the more African-American English features that you speak with, the worse performance these ASRs have on your transcription accuracy by metric of word error rate. But this doesn't answer our question of this like location thing, right? So what's going on with Rochester? And to answer that, I'm just going to show you the exact same graph, but now the points are going to have colors. Each of these dots, by the way, is one audio snippet. And so same points now with colors. You can see that in the case of Princeville, for example, which had the highest word error rate on average, there's a very high set of dialect density measures that we saw. Whereas in Rochester, which was our big question mark that had very low word error rates on average, we're just seeing that there's a much lower dialect density measure. So yes, there could be some sort of location-based aspect to this, but a lot of it can just be seen as a proxy for how many African-American English features are being said in terms of grammatical and phonological features, and not just this question of, is it location only, or is this person Black or white only as a binary? So given that we have this sort of sliding spectrum of racial disparities based not just on a binary Black or white, but on this degree of African-American English that you're speaking, why are we seeing these sorts of discrepancies? And so for the NLP people in the room, this is why I have the in 2020 disclaimer. So at some point in time, right, we had these underlying components of ASR systems that works together to generate text, right? So you would feed in your audio, you have some feature extraction, you end up having these acoustic models that deal with the phones and phonemes that you are saying. So this deals more with kind of how you're saying the words. And then these come together to feed into a language model. So that predicts the next words, comes together from the phones and phonemes to predict what next word you're saying. And so a lot of our work focused on doing this sort of process of elimination testing to figure out which of these underlying components seem to lead to that doubled word error rate. And so the first test that we did was one of lexicon. So effectively, the question would be, are the Black speakers in our study disproportionately saying words that Google or Amazon have no concept of? So if they're saying these words that are just never in the Google dictionary, that would lead to a definitively lower word error or higher word error rate for Black speakers if these words just aren't covered. So we did this test, didn't seem to be an issue. We also studied grammar. So in the language modeling component, is it the case that you have a much higher perplexity, which is another relevant metric for language models, in terms of, is it harder for the model to predict that the next word might be the result of an African-American English grammatical formulation as opposed to a quote unquote white mainstream English formulation? And it turns out that even though we do see that there are differences if you have synthetic examples by grammar, we didn't see that there were big issues overall with our particular data set in aggregate. And so what this led us to was the final test on phonology, thinking about whether acoustic models are actually the driver of these disparities that we see. And in order to do this, what we have to do is find matched set of n-grams. And so this is convenient because recall that we were using socio-linguistic interviews. So a lot of the interview prompts were things like, what was your mother's profession growing up? And so a lot of people will respond and say, and my mother was a dentist, right? So we can find a lot of those matched n-grams between the white speakers and the Black speakers and compare what the transcriptions were for those identically matched ground truths. And so of those matched phrases, if we plot them the exact same way that we plotted word error rates before, hopefully if you squint, this looks vaguely familiar, we can recover that exact doubled word error rate between white and Black speakers across APIs. And so it does seem like on our data set, acoustic models were the driver of the poorer performance for people who are speaking with more African-American English features. So overall, our data showed that we do have this doubled word error rate, but in particular, we can trace it to failures in the acoustic models across all of the APIs that we studied. And this likely has to do with the more phonological differences in African-American English speech that were being uttered by the people in our sample. And the follow-up to all of this was that actually we had a lot of calls with a lot of the relevant big tech companies. Many of them have improved their transcription for African-American English speech. Many of them went out and started massive data collection processes for African-American English speech in order to ameliorate this gap. And so we've seen a lot of progress on that front. But, and hopefully the NLP folks trusted that I would get to this slide at some point, a lot of what we studied in terms of parsing out, the acoustic versus the language model, this is no longer a thing in 2024, right? So we have a lot of changes in the landscape. We now have end-to-end models where you're training directly on pairs of speech and text. And we also have new players in the space, right? So in 2020, OpenAI wasn't yet a player. Now we have their speech-to-text tool called Whisper. And in particular, if you go into like section 7, deep into the original archive paper for Whisper, you'll see that they kind of snuck in there that also, by the way, there are hallucinations that are decidedly non-human. The model will output a transcript entirely unrelated to the actual audio. And so as an example of this, in the interest of time, I won't play the actual audio, but you'll trust that it does in fact say the following words, and it ends with the phrase, which came once a month with that. That's where the audio file ends. And if you run this exact audio file through Whisper, this is the transcription that you get. So for more information, visit www.fema.gov. Okay, so this is the type of hallucination that we're looking at. And so this was the basis for our work that came out this year called Careless Whisper. Thank you. Studying in particular these hallucinations. And so we do 3 things in this paper. We first of all figure out how frequently this happens, ending up with these hallucinations. We also taxonomize the types of harms that can occur from these hallucinations. And again, we continue to ask why. So like, why are we seeing these hallucination patterns? Does it have to do with the modeling or speech patterns or something else? And so in this particular study, we're going to pivot to thinking about differences in health status as opposed to racial disparities. And so we're going to use aphasia bank data, which has audio files that contain both the actual speech and the ground truth transcriptions for individuals with aphasia, which is a language disorder often occurring after a stroke, characterized by longer, what we'll call longer non-vocal pauses, also disfluencies in speech, more stutters, slower rate of speech, a lot of counting up to numbers and repeating words, that sort of thing. So in addition to having audio from individuals with aphasia, we also have a control group who do not have any speech or language or hearing disorders. And so we have this set of data, and we want to do a very similar thing to our first study, right? So what we want to do is compare our ground truth that we take as accurate to our Whisper-generated transcriptions. But we have a fundamental issue here, right? Which is like, we can identify where there are differences, but how do we actually know that they're hallucinations? Because we might still just have mistranscription errors, just like we would otherwise, right? So if someone's saying something about orchestra violins and that gets mistranscribed as violence, right? That's not necessarily a hallucination of the style of the FEMA.gov link. That's just a mistranscription. So figuring out how to identify hallucinations itself is kind of a tricky problem, but we ended up with kind of a clever hack, which was actually if you run the same audio file through Whisper twice in a row, the main portion of the transcription will actually stay intact. This is all set with temperature to 0, so there should be no randomness across the board. But the hallucinated portion will be non-deterministic. So the hallucinated portion will change. And so what you can do is just compare the multiply run Whisper transcriptions to see if there are large chunks that are different from run to run. And that's how we tabulate the extent to which there are hallucinations. So if anything, this is actually an undercount because there may be some hallucinations that don't change from run to run.
Even if you set the temperature to 0?
Yep, all of this is temperature to 0.
The hallucinations are non-deterministic?
Yep. This was as of 2023. So
I guess it's a little bit surprising that even though you're saying the temperature, there is still some non-determinism in the system.
exactly. Issues with the modeling to come in a few slides. Yep. So the answer to the first question is that about 1% of the audio files that we tested ended up having hallucinations in Whisper. You'll see that there were slightly more for aphasia speakers relative to control speakers. We'll come back to that in a few slides. And as far as taxonomizing, we found that on the order of 40% of hallucinations are actively harmful. And so the 3 categories of harm that we identify are some sort of perpetuation of violence. So for example, saying that someone killed someone with a terror knife, that is one actual quote from a hallucination. We have a category which has to do with inaccurate associations. So for example, saying someone is your mother or saying that you have a disability when you don't. And we also found a lot of what we call false authority. So making it sound like you are someone who you are not. And a lot of this ended up being of the genre of YouTuber speech. So you have a lot of thanks for watching. Please like and subscribe. Stay tuned next week for more. And this makes up about 40%, which is to say that the other 60% are often of the repetition genre. So you get stuck in a repeating loop of like the last 5 words that were said. So going now into this question of why are we actually seeing these sorts of hallucinations? So two paths that we'll go down. First had to do with the actual choices made by OpenAI, and second has to do with actual speech attributes. So we can actually explain away the YouTuber language with kind of the obvious, you're probably trained on a lot of YouTube data. Contemporaneous reporting found that Whisper had listened to over 1 million hours of YouTube in order to generate text transcriptions that were used to train GPT-4. So this all seems kind of consistent. But on top of that, we have this fundamental thing where Whisper, which is, this end-to-end model, likely is using a lot of the same underlying technology as any of its other language modeling technologies. And so similar to GPT, you can do things like prompt Whisper to, for example, anytime you transcribe the word and, spell it ANN instead of ANNE. So nice feature and functionality to have, but obviously leads to all sorts of issues downstream the more you're relying on the language model. So even when we have no prompts and temperature set to 0, we still end up with hallucinations. And this is in stark contrast to the other 5 ASR systems that we audited contemporaneously, where we found no instances of hallucinations across the other big players, Google, Microsoft, and Amazon. And so pivoting now to the second kind of potential explanation, which has to do with the types of speech being said. One feature of aphasia, as we kind of alluded to, is that they speak with longer pauses between words, so longer disfluencies. And so you can see that these two kind of wider distributions are our aphasia speakers, where our x-axis here is the non-vocal share of the total duration of the audio. And in particular, you can also see that the instances that ended up with whisper hallucinations also tended to have these longer non-vocal pauses. And so just to put a regression to this, in fact, if you run a logit to predict whether or not whisper hallucinates, you do see a significant positive coefficient on this particular attribute of your share of the audio file having longer non-vocal durations. Yeah.
Pauses at the in between
Yeah.
words.
At any time. Yeah, so just using voice activity VAD detection. Yeah. Okay, and so why is this a concern? So fundamentally, we worry that this is going to exacerbate biases. So we have a lot of instances where people who have, for example, speech impairments or language disorders are already going to be negatively impacted by using any sort of ASR system, right? And so having this additional concern of hallucinations is disproportionately bad for these folks. And it's not just people who have speech impairments, it's really anyone who speaks with these longer non-vocal disfluencies. So it could, for example, include the elderly or non-native language speakers, right? And this just leads to more and more harms downstream, especially in hiring or medical or carceral decisions. And so I raised medical because this APP just came out last month from the Associated Press. If you can't tell, this is actually my face. So this profile, this laptop screen is this laptop screen. So yeah, the photojournalist was very keen on making it look hackery. So that explains the photo. And so the kind of incredible thing that our journalists found is that there is a specific tool called NABLA, which is being used by over 30,000 clinicians in 40 health systems. And NABLA is built on Whisper, right? So it's a medical transcription tool built on top of Whisper for transcribing patient-doctor visits. And the kicker is that there's no way to actually validate if any of these 7 million doctor visits transcriptions are accurate because for obvious data protection reasons, patient privacy reasons, the original audio is deleted, right? So massively concerning if we're in the medical space and you want to actually verify whether or not your patient notes are accurate, you cannot. And so this is leading me to my calls to action, which are, firstly, we really need to make sure that people are more aware of these potential ASR harms. And so the onus is on the actual providers, we think. So for example, Google, Whisper, et cetera, to regularly assess their technologies. In particular, a lot of my work has to do with looking from the outside in and trying to do these sort of clever hacks to figure out how we can actually audit the internals of these products. But it would be great if the onus would be on them to do this work and do this assessment and public reporting regularly to see if there is improvement over time. And And on top of that, I think it's really important to learn from other domains, right? So a lot of progress has been made in legislating facial recognition technology, right, in policing or in AI-based hiring. And so I think more work needs to be done on the ASR front there. And of course, it's also important to invest resources into mitigating these issues. So the first is, of course, mitigating the technical issues that we find. So looking into more robust data collection or data processing for silences in audio files, updating model architectures and this sort of thing. But I also want to flag that this isn't just a data problem, it's also very much a people problem. So the more inclusive your systems are that you're building, the easier it will be for someone who's working on the system to flag that, you know, this system doesn't work for a bunch of people who speak like me, right? And so where are we going from here? Lots of ongoing work. I'm going to start with an advertisement, which is if any of you are interested in going to CHI to Japan this year, I am co-organizing a workshop that was recently accepted called Speech AI for All. Our CFP is out, I think, on December 16th. So stay tuned on Twitter or Blue Sky or anywhere else on the internet if you are interested. So aside from the advertisement, a lot more ongoing work. So thinking about continuing these genre of quantitative ASR audits, now working with Cornell to focus on the interactions between dysphonia patients and their providers. Also thinking about qualitative interviews with sociologists, working together with aphasia speakers in terms of how do they actually want to be transcribed by these companies? So if you speak with a stutter, or if you have a lot of filler words, but you might have different goals with your ASR systems between diagnosis and just, you know, asking to play a song on your playlist, how do you actually want to be transcribed? Do you want to be as faithful as possible to your speech, or do you want some sort of slightly clean version? So what do people actually want? And then lastly, a whole stream of work funded by Cisco and Apple, doing similar text-based audits on LLMs and also increasingly multimodal LLMs. So now that audio is a part of 4.0, of course, we have to look into that as well. Okay, so before going into the second half of my talk, I'll pause for questions. Great, no questions. I will keep moving forward. Okay, so was that an unmuting? Okay, I'm going forward. Okay, so second half of my talk, I want to focus on high stakes settings in particular. So no longer focusing on just the algorithm, but more what happens with it. And so this is work that was published in ICWSM in 2023 on the equity efficiency trade-off for SNAP benefits and popularizing SNAP. And so you might ask, why are you writing about SNAP in a web and social media conference? And I will clarify with two big numbers. So first big number is that the average American sees a lot of ads per day, so over 300 ads roughly. And also there are about 42 million Americans on SNAP. So if you're not familiar, SNAP was formerly known as food stamps and is a way for individuals under the poverty line to gain nutritious groceries for free, right? And so you have to apply for these benefits, and it can be extremely difficult to apply, right? A lot of times you have to submit these massive government forms that are entirely in legalese. You have to figure out which checkboxes to mark in these complicated languages. And so our collaborators at Code for America generated this website called getcalfresh.org, tell all your friends. And the idea here is that you can apply for SNAP much more easily. So it's a streamlined 10-minute process. It uses very easy to understand language, no legalese. And all you have to do is take 10 minutes to fill out the form, and then your application is in and submitted. And this form is available in multiple languages, including English and Spanish. And the way that you get people to actually get to getcalfresh.org, of course, is you have to use ads, right? So if people are searching for like, how do I apply for SNAP benefits in California? Hopefully getcalfresh.org is one of the top hits here. So the issue that our collaborators came to us with is the fact that actually very few Spanish speakers were applying. So along the x-axis here, we have the share of Spanish speakers living under the poverty line by county. Each of these little circles is a county in California. And on the y-axis is the share of Spanish speakers who are actually applying through GetCalFresh. You can see that everyone's under the diagonal. And we're going to focus on San Diego for today, where in fact about 23% of the individuals under the poverty line primarily speak Spanish. So this isn't a metric of whether or not they're Hispanic. That number is closer to 50%. This is like truly Spanish is the first language and they would prefer to fill out forms in Spanish. But in contrast, only about 10% of our GetCalFresh applications are being filled out in Spanish. So the motivating research question here is, how do we figure out how to equitably recruit different SNAP applicants, both English and Spanish speakers, via online ads? And in order to work through this, we're going to do 4 things in order. So first, we're actually going to run some Google ad campaigns and figure out what the different pricing mechanisms are. Secondly, we're going to generate some Pareto frontiers. Using those, we're going to then model what our human preferences are. And finally, we're going to do some analysis by demographic and look at how we actually want to equitably recruit SNAP applicants. Okay, so to start, why might ads be biased? There's actually a robust literature on this that often uses this term crowding out. So if you crowd some people out of the market, you end up with discrimination. What does that mean? A fantastic example is the fact that younger women tend to be much more expensive to advertise to because there's so much competition from makeup brands and clothing brands and this sort of thing. So if you're running a STEM career ad with a maximum cost per click that you're willing to pay, you end up only showing that ad to men and not younger women. So this is work from Lambrecht and Tucker from 2019. And this is kind of the genre that we end up seeing. So in our analysis, we're focusing just on San Diego. We have 2 different bidding methods that we can use that are default Google bidding mechanisms. Happy to talk more about this offline. And then we run 2 separate language campaigns. So we have one for English speakers, where we have all of the search terms being asked in English. The browser settings are entirely in English, and then we surface English language ads in response. We also have a separate Spanish campaign where all of the keywords being searched are in Spanish. People are using Spanish language browsers, and they end up being shown ads in Spanish for Get CalFresh. And so the TLDR of our experiment is Spanish ads cost more money. So no matter which bidding mechanism that you use, one of them gives you a worse trade-off and one of them gives you a slightly better trade-off. But in both cases, you end up with at least 3 times more English speakers relative to Spanish speakers because Spanish speakers are more costly. I'm going to anticipate that someone will ask why, and the answer is that we cannot tell from outside of the black box. But we do have a few guesses, one of which could be that the ML-based classifiers for whether or not an ad is spam get run before you go into the bidding algorithm part. And so it could be that Spanish language ads disproportionately get axed by the classifier. Just one explanation, many other possibilities having to do with reserve issues, or possibly nothing to do with Google at all. It could just be basic supply and demand. But getting into the meat of what we want to study now that we know that Spanish speakers cost more is this fundamental trade-off, right? So we have a set budget for running our ads, and we can either have no constraints on fairness built into how we allocate this budget, or we can build them in. And so if we have no constraints whatsoever, we might end up with some inequitable distribution, right? So mostly English speakers, because they're the cheaper set of people to advertise to. Or we can impose some constraints in order to even out this distribution. But in contrast, if we do that, we end up with fewer total conversions, right? So we're going to have fewer people who we can advertise to because they're going to be more expensive to advertise to. Meanwhile, if we stick to an inequitable distribution because we have the cheapest possible people to advertise to, we can end up with a lot more conversions. So this is the fundamental trade-off that we're going to be working with. And if we tie this into our case study where we were saying that 23% of the people under the poverty line primarily speak Spanish, so that's maybe our idea of demographic parity. But we're only seeing about 10% applicants being Spanish speakers. This is broadly mapped onto our framework. We have on one side maximizing conversions at about 10%. We have maybe demographic parity at 23%, but maybe we want to be somewhere between these 2 numbers on a spectrum, right? And so the question is, what number do we actually want to be at? Okay. So in order to figure this out, we're going to do 2 things. First, we're going to build a Pareto frontier, and then we're going to understand what people actually want out of that. So as a toy example, that actually roughly matches the real numbers. Our daily ad spend is about $400. And we could put all $400 into just the English language campaign. That gives us some number of English conversions and some number of Spanish conversions. Someone may ask, why is this not 0? The answer is because people use all sorts of different settings all the time. Maybe their child is helping them fill out an application or vice versa. So again, there are reasons that this is non-zero that are very explainable. And if we have about 40 total conversions, but about 10% total being Spanish conversions, we're roughly here on the Pareto frontier, so share of Spanish conversions. and total conversions being along our Y. Alternatively, we could put all $400 into just the Spanish language campaign, and then we get some other portfolio of conversions. So 7,13, that ends up being another dot on our Pareto frontier. But we realize we can also just do linear combinations of things. So what if we put 80% of our budget into the English campaign and 20% into the Spanish campaign? And that gives us yet another combination, which we can then plot on our Pareto frontier as well. And so once we end up with this whole curve, what we can then do is figure out where people actually want to be along that Pareto frontier. And so this now goes into the understanding human preferences portion, which is we just pick pairs. We pick pairs of points along the Pareto frontier and ask people which they prefer. So what exactly does this look like? Well, if you want to be in option A, this would be something aligning with maximum conversions. So in our pictographs, the gray color are English speakers, the blue color are Spanish speakers. And so we're going to ask people, do they prefer option A, which looks like this, or do they prefer option B, which looks like our idea of demographic parity? And so maybe just to make a question.
Just very minor, like you're asking people for pairwise preference comparison. And
Yep.
so the concern there is, how do you know you won't get a cycle which is inconsistent preferences? Why not just ask for a rank ordering or something like that?
Great question. We actually asked a number of things in the survey. So we asked in particular, do you like this idea, like as explained in a paragraph, of maximized conversions versus demographic parity? We also asked a version of the question on the margin. We found that pairwise elicitation was better for a number of reasons, partially because then you don't have to ask for every single possible combination or all 6 of these things. You can ask fewer things if you're running this at scale in your survey. So that's one quick reason. But we can talk more about this offline. Yeah. Okay. So in the classroom, I'm going to ask all of you to raise your hands. So even if you have very strong opinions about maximizing conversions versus demographic parity, it often gets very tricky when you're actually faced with 2 options. In this case, you have 36 total applicants who might be able to get SNAP benefits, of whom 13% are Spanish speakers. But this is the option where I've just swapped out 3 English speakers for 1 Spanish speaker. So now we have 34 applicants on the right side for option B, but you have a higher share of Spanish speakers. So just, there are no right or wrong answers. Who here prefers option A? A few people. Who here prefers option B? A few people, right? Like roughly 50-50 split. And the point of this exercise is just to say that it's hard to decide what fairness is, right? And so what we end up doing is we have over 1,000 people do this exact sort of exercise on Prolific, where we ask them for these head-to-head comparisons between pictograms. And the main research questions we're asking is, firstly, what demographics actually prefer this like idea of the most efficient allocation, so the leftmost thing of maximizing conversions. And the second thing we'll talk about is what allocation people actually want. And so to answer the first question, these are the post-stratified estimates for each of the demographic subgroups that we look at across our Prolific respondents. And the kind of surprising result here is that actually none of the point estimates are over this 50% mark. So actually the majority of people, regardless of what demographic split they are, always prefer some degree of equity over just pure efficiency. Okay. And the demographic group that comes closest to that 50% mark is the Republican subgroup. And that is actually also the demographic across which we see the biggest difference by demographic. So the difference between Democrats and Republicans is the largest relative to any other group. So we're going to focus on Democrats and Republicans for a bit in understanding what allocation people actually prefer most. So now we have win rates along the y-axis and the share of conversions that are Spanish for each of our surveyed options. And again, 50% means that you have a roughly equal win rate when we're comparing each of these options along our Pareto curve to each of the other head-to-head comparisons. So this is just how frequently you win in head-to-head comparisons against the other options. And the first thing to double check is that this is consistent with the previous chart, right? So we do see that Republicans prefer this leftmost option more than Democrats. And in fact, there is a greater than 50% win rate for this leftmost option. But the thing we actually care about is where the max win rate is, right? And it turns out that actually for both Democrats and Republicans, our max win rates are somewhere around that 23% mark, which was, again, our definition of demographic parity. And so the main takeaway here is actually not only is there broad support for equity, there is actually this broad support even for both Democrats and Republicans who on face value seem most different in terms of what their preferences are. And I think this is actually really interesting if you compare it to very similar analogous studies that have something to do with equity over efficiency. So if you think about affirmative action, those have really low support rates if you compare them to the rates that we found for this particular example of algorithmic-based online advertising for SNAP awareness. So hopefully this opens the door to more research in this vein. And I want to kind of end with a bit of an open question, which is how do we actually understand which human preferences we care about to take action? So we focused on Democrats and Republicans in this study, but actually we also looked at Spanish speakers and SNAP recipients, former SNAP recipients, and we see that there isn't much difference in the win rate plots for people who don't speak Spanish or for people who have or have not received SNAP in the past. So the biggest difference really is by party identity, but regardless of what you see, you're always kind of maximizing at around this demographic parity point of around 23%. And so overall, what we did is we proposed this overall framework to figure out where people want to be in terms of which allocations they think are fair. And this whole framework was actually put into practice by our collaborators at Code for America. And so this is how they ended up actually allocating ads and doing a roughly 23% baseline for splitting. And I also want to call out that this is important not just in the context of SNAP, but also in online ads broadly speaking when you're thinking about fairness in ad allocation. You have all sorts of high stakes settings like job ads and financial ads and housing ads. And I list these three because these are three instances where Facebook got sued. So with that, hopefully more work will be done. And of course, I'm also continuing to do more work on this front as well. So on the SNAP side, there is a very long pipeline that goes from knowing about SNAP all the way to actually getting SNAP benefits. So the next step of the pipeline, I think, is along the lines of you want to apply for SNAP, but you have questions, right? So you're not sure if you're a college student, do you count as a member of the household full-time? If you're a seasonal farm worker, do you count as a full or part-time worker? If you get Medicare or Medicaid benefits, how much can you take for medical deductions? So all of these questions usually go through a call center to what we call benefits navigators. And so these are the human experts who go through and actually answer all of these granular questions. But of course, they are extremely overburdened with the number of questions that they might get. And so in collaboration with a nonprofit called NAVA, and we have NSF funding for this experiment, we're rolling out RAG models of LLMs trained on these thousands of pages of SNAP documents and guidelines to see if LLMs can actually help with the efficiency of these human benefits navigator responses, or if they could potentially be harmful in terms of disproportionately raising incorrect answers, especially for marginalized populations such as seasonal farm workers. So that's one line of work, which is just continuing to go down the SNAP thread. I have another line of work on auditing online ads for gender bias, and this is in collaboration with the New Jersey Office of Innovation. And so the idea here is that their website, quick advertisement, business.nj.gov, helps small businesses figure out their taxes for New Jersey, and they just want to make sure that those ads are getting in front of their female small business owners as well. And then the last example of a project that I'll mention in this vein is thinking about gender stereotyping language, and in particular, working with lawyers who are looking at death row trials of women and identifying language that is stereotyping by gender, which is not currently protected by law, whereas racial stereotyping is, and thinking about the extent to which we can use LLMs in figuring out these sorts of tricky policy situations. Okay, so at a high level, just to wrap things up, today I talked a lot about how algorithmic systems fail in high-stakes settings, which is kind of a pessimistic way of viewing things, and to leave things on a slightly more positive note, I hope you also took away a bit on how we can ameliorate these sorts of algorithmic disparities and improve things in systems going forward. So with that, thank you to all of my collaborators and funders, and I'm happy to take questions. Thanks so much. Yes.
Thank you for the excellent talk. I really enjoyed that. I have two questions. In the first part of your presentation, I'm wondering if you distinguish between how people perhaps that language features of encryption, I believe. I mean,
Could you repeat the question? It's hard for us out in TV land to hear it.
Sure thing. Question is still ongoing. The part I've gotten so far is, do you differentiate African American English as a dialect from?
identification of
Okay.
African American identification. Basically, even among the African Americans, the diverse variety of dialect.
Exactly. And so this is exactly the point we got. So to repeat for the folks on Zoom, the question was, do you differentiate people who speak African American English from people who self-identify as African American, because not everyone who's African American speaks African American English? Is that the question roughly? Right. Well, so this is exactly what we're getting at with the racial-based disparity not just being the binary, that's the high-level reported result, but being more along the sliding spectrum of dialect density, right? So we have a range of people who are speaking with more or less features of African American English, and that is precisely because we don't see that all African Americans speak African American English. Like I mentioned, it's something like 80 to 90% can, but may not daily. There's also this question of code switching, which was really important to consider. And so actually in the Cornell data set that we used for African American English speakers, all of the interviewers in those conversations were also African American English speakers to mitigate the effect, the potential effect of code switching. Yes.
But then we have to switch to that dialect density, but then that is
Yep.
yeah, thank you. I guess one follow-up question that I had is in the is there an analysis that you had about that, like using text level? But later on, you later on needed some.
Oh, dialect density measure includes acoustic features.
Oh, okay.
Yep.
Yeah.
So it's both grammatical and phonological features.
Mm-hmm. This was a great talk. It does occur to me that there are a lot of other dialects, Texan, Mafolo Americans, and so forth, as Lyndon Johnson used to say. One of the things I'm wondering is, do any of these systems report their confidence?
Report their, sorry?
Yeah, how confident they are in their answer. Because that is really pretty crucial in medical systems, especially. That's crucial, but very broadly, it seems like your studies also could apply to understanding the variability of human transcriptions. But it's really important for these systems, it seems to me, to tell you how confident they are, or how large the set of support in their training for a particular speaker or dialect might be.
Great question. Yeah, so as far as reporting how confident individual companies are, so I guess the premise is that very few companies originally would necessarily report their word errors broadly, and if they did, it would often be on speech data sets. So the benchmarks would be speech that is effectively someone reading off Wikipedia. And so it's actually much easier to get good word error rates if you do that, because you have much less variety and variability in your grammatical structure. You're going to have fewer filler words, all sorts of stuff like this that actually matters for real day conversations. And so a lot of the word errors that you see from companies being like, we've beat all of the trends, et cetera, a lot of that historically was on data sets that weren't necessarily reflective of the real world way in which people talk, and also didn't necessarily have error bars. So short answer is, like, on average, people definitely did not used to report confidence. Increasingly, that is changing as more audio benchmarks come out. So now, as a result of my work, Coral is increasingly being used as a standard benchmark for measuring word error rate on African American English performance.
Well, what that does is that still is kind of statistically over a population as compared to my confidence in a particular transcription,
Right, exactly.
which is where the key issue really is.
And for that, I think actually a lot more work needs to be done more on the UI UX front in terms of like actually showing someone the output of, for example, how accurate a text
Yeah.
transcription is or any other sort of transcription. And so stay tuned next week for a short Nature Forum news piece where I write more about this.
Okay, well that would be good if you could also let people know the papers, because that really is a crucial issue, it seems to me, with all of these systems.
Yeah.
Thank you so much for the great talk. I have a question. Did you do any intersectional analyses of the African American speech? So, for example, did you see that there were higher error rate or differences between gender and race? So, like there were higher or error rates for Black women versus Black men. Oh,
Absolutely, yes.
okay.
Oh, no. So I showed this and I skipped over it. But I'm very glad I have this. So we did look at the differences by gender, and I actually think this is a perfect example of why we can't just throw more data at the problem. And this is very much actually also a modeling problem. Because there's basically no universe where you can say like white men are underrepresented in the training data for our audio files, right? This is just not the case. But we see across the board that men tend to perform worse than women on transcription word error rates. And a lot of this ends up being attributed to the fact that men on average speak with more disfluencies. So actually almost in tandem with the whisper paper that we did, more disfluencies generally leads to worse performance. And so we're seeing that especially for men and especially within men for Black men. Great question. Yep.
Other question. For what's it called, Cal Fresh?
GetCalFresh.org. Tell your friends. Yep.
And you mentioned policy. Was there any consideration in terms of, you mentioned policy and equity of, for example, policies that might impact the decisions around kind of the trade-offs? So for example, have the forms for that program always been available in Spanish, or was it English forms available only for, some time, and then later Spanish forms were available? So would that sort of, policy context, would those weigh into some of the decisions that were made around the ads, for example, in terms of adding in equity considerations?
For sure. So in our context, we didn't have those sorts of time-based disparities. I will say a lot of this ends up kind of reducing to actually offline things matter a lot, because fundamentally you have different populations of people who are doing these Google searches for ads. And so, for example, if you have community-based partnerships where you're actually going door to door and telling people about new things, that might be how one demographic learns more about these services, especially, for example, predominantly Hispanic communities. We were looking at Google ads, but Code for America actually also ran Facebook ads, and that was very much targeted at the elderly population. And so like you're looking at different populations through different mechanisms. And so a lot of our work, I should say, is with the caveat of like, this is for the people who are Google searching, and that might not be fully reflective of the entire landscape, especially offline, but does make a significant dent in the number of people who are applying. Yep.
It seems like, correct me if I'm wrong, like standard American English was kind of like the baseline, and then you were marking these occurrences of different like dialect features that correspond to AV. And I was just wondering, like how that could introduce bias, or how that affects how you have to interpret your results compared to if you had like done it the other way around, and for example, like use AV as your reference and then marked like features that corresponded to standard English, and also just like how you chose to select that part.
Sure, it's a good question. And a lot of this was set up by John Rickford, who is our resident expert. I'm trying to see if I can get to the slide where we list out examples. And so a lot of the way we think about these linguistic features in most variants is actually additive and less subtractive. You might have some features that are subtractive. So for example, the zero copula is something that is subtractive relative to having a copula, for example. But on the whole, when we're tagging things, if we were tagging in standard American English as well, you would still be probably tagging additively. So I don't know that that makes sense, but I do think the framing of are we starting with white mainstream English or are we starting with African American English is a super useful one. And in this context, it was effectively, we're starting from a blank slate. We just have this set of rules in a vacuum. And for each of these individual rules, how much do they occur? And it is true that these like 50 rules taken together or 100 or so rules taken together do form African American English, but a massive subset of them actually form Southern American dialects. Right, so there's actually massive overlap between like a Texas accent and African American English if you just look at the features on their own in a vacuum. Great question. Yep.
I have a question about the last part. So I'm like really, I think this, my broad takeaway is that like what you're looking at here is effectively, there's a lot of discussion about how do you decide what is considered fair, and it like seems like your approach is you can crowdsource it, which is really kind of interesting. And I guess I'm like have two kind of questions about that. So one is sort of the validity of that from the kind of research standpoint of might you get different answers if you had surveyed different people, and should this really be coming from just like general prolific workers as opposed to, I don't know, people who work in public services or something like that? And then I think the other related part of this is in the translational aspect. So given that this was actually adopted, I mean, is that from, I don't know, I guess this isn't quite policy, but from like a policy perspective, is this something that would be acceptable to use as guidance, is like what came out of like a survey result like that?
Yeah, all great questions. On the question of like who should actually be doing the survey, I think there's definitely an argument to be made that the actual like specifically targeted population should be the ones taking the survey. And so in this case, it would be if you restrict the set of, for example, prolific responses to just people who are Spanish speakers and who are former SNAP recipients. And it actually turns out kind of conveniently that for the most part, their preferences are aligned with the vast majority of the overall aggregate, and their preferences are also aligned with the other demographic that we pulled that was not on prolific, which was the Code for America employees. So the people who built Gig HealthFresh, who also had a win rate that looked very much like this. And so it was very convenient in our case because there actually didn't have to be too much grappling with who specifically we want to use as the main demographic of interest to motivate this. But a lot of work, including this Boston Globe op-ed from Meredith Whitaker, basically makes the argument that we should be focusing on the actual population of interest as the people who are deciding how they get to do this sort of algorithmic allocation. So that would be my pitch, focusing mostly on SNAP speakers or SNAP recipients who speak Spanish in this particular context. But you can get a lot of variance. I think there is definitely a reason to not stick to prolific only. And so in our case, we didn't email the SNAP recipients directly for research purposes, but that is one route that you could do. There's also the question of if you change the setting, how much do these results change? And so flipping to my backup slides now, if I can find them. So we actually did do this big robustness check of like, what if actually there's racism? And actually, like if Spanish speakers are cheaper than English speakers, what happens? And we actually see that if anything, our results are quite conservative. All of this pushes our results even further below that 50% line. If you take into account, for example, the Republican preference to prefer doing this additional equity for English speakers, even if they're more expensive. Does that answer all of your questions? It was a multi-part, so okay.
We are at 5% here.
All right. Great. Thanks so much, everyone. All right. Yeah, for everything. I'll wrap it up nicely. That seems like the thing to do.
Thanks, this was a great talk.
Thanks. I realized partway through, I was like, oh no, am I gonna get through on time? And so I just turbo speed.
Good. I didn't realize this. So I heard recently, and I haven't confirmed this, someone just like mentioned in a meeting that I think Hopkins has approved some of these like AI summarization tools for patient conversations.
Sounds about it.
Yeah, I
A
don't
lot
know.
of people are doing this.
So nice to meet
So nice meeting you.
Nice to see you.
Good to see you. Yeah, I don't